Executive Director of the Metropolitan Transportation Commission, and in that capacity I serve as chairman of something called the Toll Bridge Program Oversight Committee. That's a three-agency group that has been overseeing construction of this project since 2005. My colleagues are Malcolm Doherty, who is the Director of Caltrans, and Bimlo Reinhardt, who is the Executive Director of the California Transportation Commission. I was telling somebody before we started today, I've been working on this project since 1997. The length of this project is one of the many unusual things about the new east span of the Bay Bridge, but it's not the only one. And I am very gratified to announce today that we have reached really the last major milestone on the long construction process for this bridge until we open it to traffic less than a year away now in Labor Day 2013. And that milestone is what's called load transfer. One of the unusual design features of this new bridge is, of course, the steel portion at the deep water near Yerba Buena Island, where the bridge is a self-anchored suspension span. And unlike a traditional suspension bridge, which has earth anchorages at either end, and that's true of the west span of the Bay Bridge, as well as the Golden Gate here, as well as the new Carquinez Bridge that we built just a few years ago, our bridge does not have earth anchors. It anchors into itself. And because of that, we had two very significant challenges in fabricating and erecting the bridge. The first one had to do with the fact that the anchorage for this bridge is in the deck of the bridge itself. It's at the east end of the self-anchored suspension span. We know it by the numbers of the deck sections. There are 14 in total, and 13 and 14 are really the anchor decks. And if you've ever seen or been in one of the earth anchorages for our bridges, you'll remember that they are immense concrete structures. They're huge, stories and stories tall, and they're almost cathedrals of concrete into which these suspension bridges are anchored. We have a bit of a crawl space underneath the east end of the bridge, and all of that workings, all of that anchoring has to occur within that very tightly confined space. And as you might imagine, that presented a very significant fabrication challenge when we had to make that space out of steel. Add on top of that the fact that that part of the bridge just happens to be at a curve and a bank, and you can see the kind of complexity that we had to deal with. So that was really the first major challenge, a fabrication challenge for getting this self-anchored suspension bridge completed. The other one, the one we're celebrating today, load transfer, involves the fact that since this is a self-anchored bridge and it essentially holds itself up, until we completed that engineering mechanism, the bridge needed to be supported on temporary false work. And that temporary false work is quite visible today. We've started as part of this operation to remove some of that false work, because what's happened over the last few months is the deck has been connected by those suspender ropes that you see out on the span. The bridge has been attached to the cable, the main cable, and the main cable on our bridge functions just like the main cable on a typical suspension bridge. It holds up the decks. And so what we've completed today is the culmination of all of the work, all the design effort, and now the bridge is supporting itself, and it is functioning as a suspension bridge. So that is the milestone we announced today. It is, I think, it's fair to say, a pretty big collective sigh of relief for all of the engineers working on this project. There was never any question that the bridge would hold itself up. The question was, when they picked it up, would they pick it up right the first time? Or would we need to be tuning it and tuning it and tuning it? That was the fear, and I'm pleased to say that that fear in this case was unfounded, and they picked it up right the first time. And I would certainly like to congratulate our contractor, American Bridge Floor for a really excellent professional job on this activity, as they have on everything else that they've attempted on this marvelous bridge. What we have left to do after today is a lot of more meat and potatoes kind of work, you might say. We've got a lot of painting to do. You might have seen that some of the suspender ropes have been painted. The bridge is going to be all white, sort of like these construction cranes that are over here in the East Bay. There will be a lot of road work to do, the striping, a lot of the guts of the bridge, the mechanical and electrical work needs to be completed. And what we could really use this winter is a bit of a drought, which happens every so often in California, and we wouldn't mind one for the next several months so we can get the thing painted up. What I would liken it to is we're unwrapping a present. We're unwrapping a gift for our region. And I think one of the most important things about this project is it's not just a gift to the people who are paying for it today, all the toll payers who drive across all of our bridges, but it's a gift to future generations, because this is a project that will last 100 years or more. And in my opinion, our generation hasn't been doing all that good of a job in passing on gifts and infrastructure to the next generation. And in this case, I think we can be proud that we are doing so. And we're certainly very pleased with the milestone that we've reached today. And we can smell the finish line now. And we are going to put the pedal to the metal and get this new bridge open to traffic as quickly as we possibly can next year. So I think, Bart,